Hello everybody and welcome to my 21st video. This is on quaternary truth tables and functions. So first of all, I'll be going through how to generate the input combinations for a function. Here we have a 1 input function, a 2 input function and a 3 input function. Now the rule is the number of consecutive zeros, ones, twos and threes is 4 times the number to the right of the column to the right, starting with 1. So here we have A 0, 1, 2, 3, and here we have A and B 0, 1, 2, 3, and the pattern repeats. Then 4 zeros followed by 4 ones, followed by 4 twos, followed by 4 threes. Here for a 3 input function A, B and C, A follows a pattern 0, 1, 2, 3 and the pattern repeats. B follows a pattern 4 zeros followed by 4 ones, followed by 4 twos, followed by 4 threes and the pattern repeats. Same for these ones. And column C, you've got 16 zeros followed by 16 ones, followed by 16 twos, followed by 16 threes. This is the easiest method of generating the input combinations for a function. Functions here I haven't listed. There could be any combination of 0, 1, 2 and 3. Here we have some unary operators. Here we have an input A, and A plus is A plus 1 modulo 4. A plus plus is A plus 2 modulo 4. A minus is A plus 3 modulo 4. And these are two valid unary operators here. A1 is a 1 if A equals 0 and 0 otherwise, as here. A2 is a 2 if A equals 0 and 0 otherwise. And A3 is a 3 if A equals 0 and 0 otherwise. That's there. And A bar is 3 minus A. So, yeah, 3 minus A. These are two valid unary operators for another algebra I'll be presenting. Like I say, I'll be presenting these as an algebra and then these as an algebra with the maximum and minimum of functions. So these are two valid unary operators, as I've said, and A, capital A, B is 3 if capital A is greater or equal to A, but less than or equal to B, and 0 otherwise. So here 0, 0, A is 3 at 0 and 0 otherwise. A1, 1, A is 3 at A11 is 3 at 1, A equals 1 and 0 otherwise. A22 is a 3 at A equals 2 and 0 otherwise. A33 is an A is a 3 at A equals 3 and 0 otherwise. A01 is a 3 at A equals 0 and 1 and 0 otherwise. A12 is a 3 at A equals 1 and 2 and 0 otherwise. A23 is a 3 at A equals 2 and 3 and 0 otherwise. A02 is a 3 at A equals 0, 1 and 2 and 0 at 3. And A13 is a 3 at 1, 2 and 3 and 0 otherwise, at 0 at 0. Right. So here, as I mentioned before, this is a minimum function. This is A and B represented by a dot. Min A dot B is min AB. So this is the output of the minimum function. These are the input variables A and B. So I'm going to show you how to fill in the output of the function. First of all, step 1, you look for an input, a 0 on any of the inputs, and you write a 0 on the corresponding output. So this is step 1 here, 0 there, 0 there, 0's there. Step 2, next you take the ones, you look for a 1 on any of the inputs, A and B, and you write it in the output. So that's step 2, 1 there, 1 there, next you take the 2's, you look for a 2 on any of the inputs for the remaining ones. So that would be there and there, a 2 there and a 2 there. And lastly, you look for 3's on any of the inputs and you write it on the output. So there's only one 3 when all inputs are equal to 3. So that's there. Okay, so that's the minimum function. So this is the maximum function. A plus b equals max AB. I'm using the plus sign to signify the max function, as with the dot to signify the minimum function. So here we have the output of the maximum function, inputs A and B. And again, I'm going to show you how to fill in the output column of the function. So step 1, you look for a 3 on any of the inputs and you write a 3 on the corresponding row of the output. So 3 is there. Next you take the 2's, you look for a 2 on any of the remaining rows of the function. So a 2 there, a 2 there, and 3 2's there. Next you look for a 1 on any of the inputs for the remaining ones. So you've got 1's there and 1's there. And lastly, you look for a 0 on the outputs on any of the input combinations. This will only be when all the inputs are 0, so that's a 0 there. So that completes the table. Right. Here we have the difference of function. Now this function is useful for comparing if two inputs A and B are equal, because the output will be 0, and that's the only time the output will be 0. A difference B is the absolute value of A minus B. So for example, 1 minus 3 A minus B is minus 2, but you ignore the sign and it's 2. So that's the input. It's a 2-input function only, and like I say, it's useful for comparing if two inputs are 0. I'm representing the difference of function by a tilde between A and B. Next we have the sum function. Sum function A plus B is A plus B modulo 4. And basically it does what it says on the tin. I've represented A plus B like the binary exclusive OR symbol for the sum function. The way you calculate modulo 4 is you take the remainder of the number when it's divided by 4. For example, 3 plus 3 is 6, and 6 divided by 4, well, 4 goes into 6 once, remainder 2, and that's the remainder there too. So that's how you calculate the A plus modulo 4 arithmetic function. Next we have the product function is A times B modulo 4. Again, inputs A and B. Anytime you get a 0 on the input, you get a 0 on the output. Because 0 times anything is 0, 1 times 1 is 1. So I've used a cross in a circle to represent the multiplication of A and B. And I say A times B mod 4 is the same. Modulo 4 is the same as calculations as A plus B mod 4. For example, 3 times 3 is 9. 4 goes into 9 twice, remainder 1. So here's the remainder 1. Right, I think that concludes the presentation. I'd just like to say thanks for watching. I hope you've enjoyed it. Bye.